Hi, I just thought I'd go over the Chapter 6 review in case you have any questions on how to do any of the problems. So the first couple are on end behavior, and what we need to know about end behavior is we need to look at the exponent, and if that is odd or even, in this case it's even, and if it's even, that means they're both going up or they're both going down. And then we also look at the leading coefficient. In this case, it's -1. So we just care if it is positive or negative. So it's negative. So that means our graph is going to be pointed down, both of them, like this. I'm not really sure how that got like that, but anyway, so what you're going to do is you're going to write as x approaches -infinity, f of x approaches -infinity. That's this side right here. And as x approaches positive infinity, f of x approaches -infinity because it is still heading down. If you had even but positive, so if you had like x to the 4th, but it was positive up here, then you're going to have where they're both heading to positive. Let's take a look at the next one. We have an odd exponent because it's just 1, and we have a positive leading coefficient. So that means it's going to look kind of like this. As x approaches -infinity, so that's the left side, then f of x is going down to -infinity. And as x approaches positive infinity, f of x approaches positive infinity. If we had the opposite of that, so let's say we had negative x to the 3rd, then it's going to look like this. So then as x goes to -infinity, f of x goes to positive. And as x goes to positive infinity, f of x goes to negative. All right, evaluate f of 1 if, and you have this piecewise function. So this is what we do. We take our 1 and we just decide what domain it fits into, okay? So in this case, 1 fits right in here because x is greater than or equal to 1. So that means I use this expression and I plug my 1 in for x there. So 1 plus 4 is 5. So f of 1 equals 5. This one here, we are given a piecewise function, and then it says to write the rule for a transformed function, so g of x, when there's a vertical translation 2 units up. So if there's a vertical translation, remember there's no change in domain. Okay. So this part will stay the exact same. But we do get to change the rule a little bit. So going 2 units up, we're just going to smack a +2 at the end of both of those. So now my new piecewise function is going to be 2x minus 2 plus 2, or just 2x, and -4x plus 16 plus 2, or -4x plus 18. And x is less than or equal to 3. X is greater than 3. So those do not change. That's supposed to be a 3. Down here, we have a horizontal translation. That means the domain does change. So does affect domain. Yeah. So translation 7 units right. Well, I need to take this bit by bit here. So if I'm going to change something 7 units to the right, that means I'm going to have x minus 7 inside the parentheses. And then I'm going to simplify it by distributing 3x minus 21 plus 2. So to write my transform function, I'm going to have 3x minus 19 for this part. And x is less than or equal to, I'm not going to write 0 because it went 7 units to the right, so I'm going to add 7. In the second part, we'll take our x squared, but we have to subtract 7 inside the parentheses like this. So if I'm going to FOIL this out, because it's a binomial squared, it's the same thing as having x minus 7 times x minus 7. So it'll actually look like x squared minus 7x minus 7x plus 49, or x squared minus 14x plus 49. And then again, my domain will change so that x is greater than 7. So this would be my final answer. Okay, those were the first 5. I'm going to switch pages. Okay, we'll go through the next few. So this one we're just finding f of g of -2. So we have this composition. So what we're going to do is we're going to put -2 inside of the g function first, then take whatever we get and put it inside the f function. So if I put a -2 in for x, I get 8 over -1, so I get -8. So that means I have f of -8. And if I plug -8 into the f function for x, I get -10. So f of g of -2 equals -10. Here we have the same starting functions, f of x and g of x, but now we need to write a rule for the composition f of g of x. So I'm going to take the g of x function and I'm going to put it inside of the f of x function for x. So f of g of x is going to, instead of the x, I'm going to write this. And I don't think I would worry about simplifying that at all. You really don't need the parentheses. But it does say state the domain. So remember, domain is all real numbers unless you have an x in the denominator or underneath the square root sign. In this case, we have an x plus 1 in the denominator. So x cannot be a -1. We'll do it the other way, where we have g of f of x. So g of f of x, I'm going to take my f function and put it inside for x in my g function. So it's going to be 8 over, and then I'm going to have x minus 2 plus 1 here. I'm going to simplify that a little bit because I really don't need those parentheses, so it just has x minus 1 on the bottom. Can't really simplify that anymore, so now I'm just going to write my domain. X cannot be +1. So that's my answer. All right. There's a few more that do the same sort of thing, but with different functions. So if we have g of f of -3, I'm going to put -3 in for my x in my f function. So I get 9 plus 8, so I get 17. So then I'm going to come put 17 in for this x here. 17 minus 1 is 16, and the square root of that is 4. So g of f of -3 is 4. Let's write a f of g of x function. So I'm going to put g function inside of the f. Oops, yeah, that line got too long. So f of g of x equals, and I'm going to have this squared, which is square root x minus 1, and then I still have my plus 8. I'm going to simplify this a little bit. I'm going to get rid of the square root and squared sign because it just cancels each other out. So I'd have x minus 1 plus 8, which is just x plus 7. Now because I started with an x under the square root. I'm going to have to look at that when I'm deciding the domain. So the domain is that x cannot equal a positive, but I'm going to lie to you. X has to be greater than or equal to a positive 1. Because if I put anything else in there, it's going to be negative. All right, last one on this page that I have, we're going to do g of f of x. So this time I'm going to put the f function inside the g function. And so it's going to look a little bit like this. I don't need the parentheses, so I will just simplify it to x squared plus 7. And then I asked, well, is there anything that cannot be put in here? Is there anything that would make this negative underneath? And because this is squared, no, I can put anything I want into that. So my domain is going to be all real numbers. One last page. Let's do some inverses. So remember, to find the inverse, you've got to swap your x and your y. So I'm going to just kind of remember this is just y. So now I'll flip my x to this side and my y like this. And then I'm going to solve for my new y. So I'll start by multiplying by 6. And then I'll subtract 9. And then I'm just going to divide by 5. So I have 6x minus 9 divided by 5. That's a 6. It's a terrible 6. And it's going to equal y, or I'll use function notation. Same sort of thing with this next one. So this is just y, so I'm going to swap them. So it says x equals the square root of 2y plus 5. I'm going to start by squaring both sides. So I have x squared equals 2y plus 5. And I'm going to subtract 5. So I have x squared minus 5 equals 2y. And then I just need to divide by 2. So I have x squared minus 5 divided by 2 equals y, or function notation right here. And the last one is to determine by composition whether these two functions are inverses. So remember, we need to go f of g of x. And if that simplifies to just an x, that's good. And then we'll do g of f of x. And if that simplifies to just an x, then they are definitely inverses of each other. So I will put the g into the f function. So I have 1/4, and instead of writing x squared, I'm going to write 2 square roots x like this. And I'm going to start simplifying. So I'm going to distribute that 2. So I have 1/4, and then I have 2 squared, which is 4. And then I have square root of x squared, which is x. And 1/4 times 4, so that's just x. Okay, so good. That one simplified to x. Let's see if this one does the same. So now I'm going to put the f function into the g function. So I have 2 square root of, and then I need to write 1/4 x squared. And I'll start simplifying. So I'm going to break my square roots down to the square root of 1/4 and the square root of x squared. Well, the square root of 1/4 is just 1/2. And the square root of x squared is x. So this simplifies to x. And so yes, the answer is they are inverses of each other. Okay, let me know if you have any other questions on this review, and good luck on the test.